Hello students, future doctors and engineers. Welcome to our YouTube channel Medji Exam, the platform where smart work is always preferred over hard work. I am Pawan Shah with cream of the theme series in physics, starting with class 12. Today we will discuss part 2 of chapter electric charges and fields. The topic covered will be electric field and electric field intensity, Coulombs law in air or vacuum and in medium, and permittivity and dielectric constant. So, first of all, electric field and electric field intensity. What is electric field? Electric field is the space around a charge up to which its effect is experienced. Let here is charge placed Q, and we take a test charge. Test charge, what is actually test charge? Test charge means the charge which is used to test charge. Test charge means charge which is used to test the effect of other charge. As for example, as we have taken, this is a point charge, and if we take a test charge, let it is Q naught. We are placing test charge here Q naught. If this Q naught experiences force, then we say that yes, this charge capital Q has its effect up to this area. Let up to this, it has its effect. But beyond this, if you place Q naught, then this Q naught is not affected by this capital Q. Then we call it as the Q has no field at this. And we say that in this situation, we see that this Q naught is at infinite distance from this Q. Q naught is at infinite distance from this Q. So Q naught is the test charge used to test whether a particular charge Q has its effect at that region, on that region or not. So Q electric field is the region in space. This is the region in space up to which the effect of this capital Q is experienced if you place any other charge. We call it as test charge. Now here, most of the time we use this test charge as positive. So it is by convention that test charge means positive test charge. Positive test charge. And the amount of test charge is generally, this test charge is generally taken in such a that it does not affect the field of this stationary charge or this charge. So most of the time this Q naught is taken very small, and in such a way we define here unit positive test charge. Unit positive test charge. That means plus 1 Coulomb is said to be unit positive test charge. Used to test the electric field, used to test the space of the charge around which it can show its effect. And that is called as electric field. So electric field is the space up to which a particular charge has its effect. That is called electric field. And that is tested by, test charge. Or we can say it as unit positive test charge. Okay. Now the electric field intensity. Now suppose this is a point charge Q and this has filled this much. Let it has filled this much. And if we place in this any test charge, let Q naught. Test charge means positive charge. We have placed a test charge Q naught. The force experienced by this test charge at this point due to this capital Q charge is said to be electric field intensity of this capital Q charge. If this distance is, and this Q naught here, it should be plus 1 Coulomb. That means unit positive discharge. If this distance is R, then from Coulomb's law we can say that the force experienced will be Q into Q naught, magnitude of Q into magnitude of Q naught, upon, if distance is R square, then it is R square, this, and a constant, that is K, or we can say 1 upon 4 pi epsilon naught, that constant, if it is air medium. Then this is the force, magnitude of force according to Coulomb's law. If we take this Q naught as 1 Coulomb, then this force will become E. That is electric field intensity. That will be K Q upon R square. KQ upon R square. And for direction, we can keep unit vector. If you want here also put the direction, we can keep here also unit vector. Okay. Or if this Q naught is not plus 1 Coulomb charge, any other positive charge, such that it doesn't affect the field of this capital Q charge, then we can write like that, F upon Q naught, that will be again equals to KQ by R square R cap. This F upon Q naught again will become electric field. So what is electric field intensity? It is the force experienced. What is electric field intensity? It is the force experienced by a unit positive test charge when placed in an external electric field, or we can say electrostatic field. We are doing electrostatics, means when properties of charges when these are at rest. So we can say this as electrostatic field also. We can say this all as electrostatic field also. Okay. So as force is a vector quantity, similarly electric field intensity will also be a vector quantity, so it is a vector quantity. And as I have shown here, E will be equals to F upon Q naught. Q naught is the test charge. It is the test charge. Okay. Or we can write in this way also. So again another formula become KQ upon R square R cap. Okay. If you see the dimensional equation or dimensional formula of this electric field intensity, then from this formula E equals to this formula E equals to F upon Q naught. We know force has the dimension MLT minus 2 and Q will be A into T. From that we can write this. So this is the dimensional formula. Its SI unit will be volt per meter. SI unit of this electric field intensity will be volt per meter. So electric field intensity and electric field, there is difference between that. As we have seen earlier here, electric field intensity is the space around a particular charge up to which its effect is experienced. But this is the electric field, but electric field intensity is the force experienced in that electric field. If we keep a test charge or unit positive test charge, if we put a unit positive test charge, then force experienced by that unit positive test charge inside that electrostatic field or electric field is known as electric field intensity. So electric field intensity is a kind of force, we can say, definitely, in which one charge has some value but another charge has fixed value, that is of plus 1 Coulomb. Then, and that force experienced by this plus 1 Coulomb charge or unit positive test charge is said to be electric field intensity due to this charge, stationary charge, or whose field is created. Okay, so this is about electric field intensity. Now, we can write Coulomb's law. We have studied in previous part 1 Coulomb's law. We can write Coulomb's law in this way. F equals to 1 upon 4 pi epsilon naught q1 q2 upon r square. We know that this value of this 1 upon 4 pi epsilon naught q1 q2 is experimentally in SI unit is found to be 9 into 10 to the power 9. Okay, value of this 9 into 10 to the power 9, numerical value of this. Okay, if you put here constant, that equals to, if you put constant k and in any constant k, then its unit will be what? This constant k will be, that will be equals to 9. This is the numerical value, but if you want to write along with the unit, then we can write 9 into 10 to the power 9, and it will be Newton per Coulomb square and per meter square. Because this k is here, if it will go to that side, r square will be there, and q1 and q2 will be go downward. So Newton per Coulomb square per meter square, that will be the unit of k. Here this is known as absolute permittivity. Absolute, we will deal later on. Absolute permittivity, or we can say permittivity of the air or vacuum. Permittivity means the medium how much permits the two charges to exert force on each other. That is the permittivity. And air medium has fixed value or vacuum has fixed value. So from here, if we want to calculate, we can calculate this E naught will be, the value of this E naught will be absolute permittivity of air or vacuum, that will be 8.854 into 10 to the power minus 12, and unit will be Newton per meter square per Coulomb square. Here we have written that unit. See, if we have to calculate, the Coulombs law in any other medium other than air or other than vacuum, then we can place, in place of epsilon naught, we can place this, that is k epsilon naught. We can place k epsilon naught. This k epsilon naught is known as epsilon m. Epsilon m is permittivity of the medium. This epsilon m is known as permittivity of the medium. Permittivity of the medium. And this k is known as, we will deal later on, this k is known as dielectric constant of that given medium. Dielectric constant of that given medium. Okay, and as dielectric constant has no unit, so epsilon naught or epsilon m, permittivity, absolute permittivity of the air or vacuum, and permittivity of the medium, both will have same unit and same dimension, same dimensional formula or equation. Okay, so see, if this is, this is air medium, and in this we place charge capital Q or Q1. We can write it also as Q1. We can take it also as Q1. If we place charge Q1 here and Q2 here, and shortest distance between these two charges are R, and this is the air medium. Then we can write force F, magnitude of force. If you want to write that, we can write, and if you want to write direction, we can give the unit vector. F will be equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. But if this is another medium, let it is water medium, and if you keep the same charges Q1 here, Q2 here, and at the same distance, then that force will be, or magnitude of force, if you want to find numerical value, that will be 1 upon 4 pi epsilon naught k Q1 Q2 by R square. This k has, in case of water, which is known as dielectric constant of water, this k has value 80. That means two charges, same distance, placed in different medium, then they will exert different forces on each other. And from here we can see that this force is this force in water. If you compare these two, then here this force in water upon force in air, if you write like that, force in air is this, force in water is this, that will be equals to how much? Force in water and force in air. Force in water has formula 1 upon 4 pi epsilon naught K into Q1 by Q2. And force in air has formula 1 upon 4 pi epsilon naught Q1 by Q2. So finally what we see? Finally we see that from these two equations, finally we see that this Fw, magnitude of Fw and F air will become equals to how much? 1 upon K times. Means force in water decreases by K times force in air if the same charges are placed at the same separation between these two different medium. So this says that from this we can implies that, or from this we can understand that yes, if you change the medium, the force will be affected, and force of that is affected depend on the dielectric constant K of that medium. Okay, we will see next in detail all this. First, let us see the permittivity, definition of permittivity and dielectric constant, what we have discussed in this Coulombs law. So permittivity is the property of the medium which determine electric force between two charged particles in that medium. Okay, so what will be the amount of electric force? That also decided by the property of that medium in which charged particles are separated by some distance, and that is known as permittivity. Absolute permittivity. Permittivity of the medium, air medium or vacuum, is said to be absolute permittivity. Is said to be absolute permittivity. And permittivity of the medium, definitely it is the property of the medium which allow electric forces between two charges. That is called permittivity of the medium. Okay. Now, another thing is relative permittivity. That is the ratio of permittivity of a medium to the absolute permittivity is called relative permittivity of that medium. Means we have to take the ratio of permittivity of medium. We have to take the ratio of permittivity of the medium to the permittivity of the air. This is known as relative permittivity ER. This is known as relative permittivity ER. And this relative permittivity ER is also known as dielectric constant K, as we have seen the earlier. EM equals to, discussing the Coulombs law, we have seen that EM equals to K epsilon naught. So from here, K will be what? EM by epsilon naught. But EM by epsilon naught is also ER. So ER and K both are same. So relative permittivity, we can say relative permittivity also as dielectric constant, which is the property of the medium. So relative permittivity is also known as dielectric constant, and that we can see this. So we have formula for relative permittivity or dielectric constant: EM by epsilon naught M by epsilon naught E, epsilon naught ER equals to K, that equals to K F naught by M, Fm. That we can write. That we can write. Or we can write this, because F and E are same. E are also force. Electric field intensity is also force. F is also force. So ER, that can be written, or dielectric constant, that can be written in this form also, E naught by EM. In that form also we can write. See, again, just I am recalling you, if you write force, magnitude of force for air medium, then that we can write 1 upon 4 pi epsilon naught Q1 Q2 upon R square, magnitude. And if you write that in case of medium, any medium, then we can write that force as 1 upon 4 pi epsilon naught K Q1 Q2 by R square. Okay, this. But if you take the ratio of this force, if we take the ratio of these two forces, that is F air, here we have written F naught here. Same thing, F here. F here by Fm if we write, then it will be equals to how much? 1 upon 4 pi epsilon naught Q1 Q2 by R square, that is F air, by this will be 1 upon 4 pi epsilon naught K Q1 Q2 by R square. And this implies F naught by Fm, that will be equals to K, that will be equals to K, because always K is considered, this will go up. So this become equal to this K. Similarly, as if you divide the force by unit positive test charge, then we get the electric field, because we have formula E equals to what? F by Q naught, magnitude. So if we divide the force by the Q naught, then we get E. So we can write similarly again for dielectric constant in this form also, E naught by Em. So dielectric constant, formula for dielectric constant K is Em by E naught. Again here it is E naught by Em, epsilon naught M by epsilon naught, F naught by Fm, all that. See, as when air medium is there, here no K is appeared. So that means this implies that K is, value of K is 1 here, in this case air medium. So we have written value of K is 1, and K for water is 80, K for metal is infinity. K for metal is infinity. Okay. So this we have to remember, K for metal is infinity, or we can analyze this, see why this K for metal become infinity. Just I am explaining a little bit. Let here is charge point charge Q1 or any charge Q1, here is another charge Q2, and in this between this we place a medium. This medium is a metal. How does charge exert force on each other, or how does charge interact? The charge interact with each other by the electric field. Electric field means in between the charges electric field exists, and due to that the charge particles exist. But when we place metal between this, the electrostatic field inside the metal become 0. Inside the metal become 0. That's why this charge cannot interact with this. And in this way, this charge cannot able to apply force on this. That means force applied on this due to this charge on this charge, or force applied due to this charge on this charge. If a metal conductor is placed between these two charges, then it will be 0. That means force applied is 0. That means what? With respect, that means what? Dielectric constant is how much? Infinity. Then only it can be possible that force apply will be 0 if K is infinity. Dielectric constant is infinity. That's why K has K for metal is infinity. Okay. Okay, students. If you want to download the PDF, link has been given in the description box. And if you like the video, then like, share and subscribe to our channel. And for today, thank you.